Hello students, I hope you all are doing good. So we are going to start with the very first chapter of 8th standard, that is rational numbers. And I hope like most of the students are well aware of integers, as I have already explained it in the first part of the video. So let's start with the rational numbers and let us begin with the definition of rational numbers. According to the definition, a number which can be expressed in the form of a ratio b, which means a upon b. A number which can be expressed in the form of a ratio b, that is a upon b, is called as rational numbers. This is the basic definition of rational numbers. Any number which can be expressed in the form of a upon b is called as rational numbers. Now what is a and what is b? Remember, a and b both are integers. First condition, what are a and b? A and b, they both are integers. Now integers can be positive and integers can be negative as well. So a upon b is a rational numbers where a is an integer and b is an integer. It doesn't matter whether they are positive integer or negative integer. So this is the first condition, that if you want this number, that is a upon b, to be a rational number, a and b both should be integers. I'll write it down. Can be positive and negative. They can be positive and they can be negative. Alright? Okay, now the second condition. It says that if a upon b is a rational number, then the number b should not be equal to 0. It can be any number but not 0. Make sure that if you want a upon b to be a rational number, then the denominator b should not be equal to 0. This is another important condition for a rational number. Alright? Okay, so these are the basic definition of rational numbers. Let us try to take some examples now so that you can better understand this term. If I say 1 upon 2, is this a rational number? Yes, of course it is a rational number. Why? Because 1 is an integer and 2 is an integer. Let's take one more example. If I say 1 upon minus 7, is this a rational number? Yes, of course it is a rational number. Why? Because 1 is an integer and minus 7 is also an integer. And that is something else. It is a negative number, but it is a negative integer. And according to the definition, it can be positive as well as negative. So both should be integers, either positive or negative. Let's take some more examples like minus 11 upon 4. Is this a rational number? Yes, it is a rational number. We can take minus 2 upon minus 7. Is this a rational number? Yes, it is a rational number. Why? Because both are negative integers. Alright. So these are some examples of rational numbers. Now do one thing, students, pause this video for a while, copy down the definitions as well as these examples so that we can proceed further. Okay students, after that I have written certain properties of rational numbers and they are very important. Try to understand. First one, it says that all integers are rational number. What does it mean? Suppose we have got one number, that is 5. Now if I ask you like, the number 5 is a rational number or not? It's quite confusing. So what is the concept? Let's try to understand. 5 can be written as 5 upon 1. Is it correct or not? It is correct. Why? Because if you are going to write 5 as 5 upon 1, it is not going to change the value of 5. Now here 5 upon 1, 5 is an integer, positive integer. 1 is also a positive integer. It means 5 upon 1 is nothing but a rational number. Alright? That is why we say that all integers are rational numbers. I have written certain examples. For example, 2, minus 5, 7, 9. These are the certain numbers. They are integers, positive and negative integers. But if I write 1 below each number, like in the denominator, if I write 1, suppose 2 upon 1, minus 5 upon 1, 7 upon 1 or 9 upon 1. All these numbers are rational numbers, because 1 written at the bottom will not change the value of the fraction. The value of the fraction or the number remains constant. That is the reason we say that all integers are rational numbers. Now second point, it says that every rational number can be written as terminating or repeating decimal numbers. Now what does this mean? It means that every rational number can be written as terminating or repeating numbers. How? Because if you are going to write any rational number and if you are going to divide the numerator by the denominator, you will get a repeating decimal value. That is the reason it is said that every rational number can be written as terminating or repeating decimal numbers. The third point and the last one, it says that all numbers which are not rational are called irrational numbers. Which means, see, there are two kinds of numbers so far which we have studied, rational and irrational numbers. If the number is not rational, the number will be irrational number, or it will be called as irrational numbers. Now students, generally the irrational numbers are written in under root sign, like under root 2, under root 5, under root 7. They all are irrational numbers. Now the basic difference is that the rational numbers are the terminating ones, which means they have repeating decimal numbers, but the irrational numbers, they are the non-terminating ones and they are non-repeating decimal numbers. It's very important. Just learn this concept. Alright, that the rational numbers are the terminating and the irrational numbers are the non-terminating ones. So these are the 3 points and they are very important. Students, do one thing. Try to write down all these points in your copy. Pause this video for a while, and once you are done with all the 3 points, we will proceed further with some new concepts.